Today we are going to be introducing our factoring unit. So starting with 6.1, today we're talking about greatest common factor and grouping and how we can factor polynomials using these two things. So we'll start off, we're going to fill out this table. And you'll notice on one side of the table it says standard form, which is just a polynomial placed in order based on the degree. Okay, and if you notice, highest exponents come first. Okay, we call that descending order. And then on the right side, it has factored form. So this is when we've broken down that polynomial into its simplest form. So if we look at this very first one, they've got it in both forms for us. Okay, so if we look, we've got 2x squared plus 4x. That's the standard form. Okay, the x squared is higher than the x, which is why it's written in that order. Factored form, though, what they did was they noticed that this 2x squared and 4x had something in common, okay? And that was 2x. That is their greatest common factor. So a 2x would go into both those terms, and when they divided both those terms by 2x, they were left with 1x plus 2, which we write in parentheses, because we took out the 2x. You with me so far? Okay, so we're going to look at our second one. This one's a little easier. 3x plus 6. What do both of those have in common?
Greatest common something is 3.
3. The GCF is 3. Awesome. Do they have any variables in common? No, because this one's got an x, but this one doesn't. So you can't take out a variable if they don't both have it. But you can take out a 3. And then what's going to be left? Well, first term, 3x divided by 3 would be what? Divided by? Just x, right? Those 3's would cancel. It's okay. And then if we divide the 6 by 3, what's going to be left there? 2. So plus 2, because it's positive. And that is how we factor. Okay? Braden, you all right?
I don't get that. I don't get the first one.
You don't get the first one?
No.
Okay, so first we looked at the coefficients. Okay, so 2 and 4. What will go into both 2 and 4? 2. Okay, so that was our first part of our GCF, which we have right here. Okay, and then what about x squared and x? What do they both have? Just x, right? They both don't have x squared, but they do both have 1x to the first. So we also included that in our GCF, okay? So that's why our GCF was 2x here.
So the square is just nothing.
The squares are nothing?
The square on the first.
No, I mean, it is something. So whenever we had our GCF here, that 2x, we divided both of these by 2x, okay? So the first term, the 2's canceled. And then x squared divided by x is just x to the first, which is how we got our first term, 1x. And then when we divided the second term, 4 over 2 just becomes 2, and the x is canceled. So that's how we got this 2 over here. Does that make sense? Okay, we're going to do more, so don't freak out. Okay. The next one, though, it's already got it in factored form, and it wants us to put it in standard form. And we have done a little bit of this. You should have done a lot of it in Algebra 1. But whenever we have a term out front, we already know we have to do what with it? Starts with a D. Distribute, right? Okay. So first term, 3x times 2x squared. Let's just start with the coefficients. So 3 times 2, 6. Okay? And now we have x times x squared, or x to the first times x squared. When we multiply two things that have a like base, what do we do with their exponents? Add them, okay? So x to the first times x squared, what's 1 plus 2? 3, so that's going to be 6x to the third. Everybody see how we did that? 3x times 2x squared is 6x to the third. Okay? And then the next one, 3x times negative 10. So we'll just do coefficients. 3 times negative 10. Okay? And x to the first times, there's no x's on that one, so we just leave it as x to the first, or just x. And that is our answer there. So we put that in standard form. X to the third, that's a bigger exponent than x, which is why that one's written first. So we leave it. Questions on that? Okay. We're going to do a few more here. Okay. What's different about this one? How many terms do we have now? 3 terms, okay? It still works when we have more than 2 terms. So if I look, I've got to find, we'll just start with coefficients first. 4, 12, and negative 24. What's a number that can go into all 3 of those? 4. Okay. Now look at the variables. So we got x to the third, x squared, and x. What do they all have?
X.
Just x, right? They don't all have 2, they don't all have 3, but they all have at least 1. So x to the first. Okay? Now we're going to have what's left in these parentheses. So my very first term, 4x to the third, when I take out a 4x, what's going to be left?
What?
So I'm taking out a 4x from my first term. Just x squared, good. Okay, that's because the 4's are going to cancel out. And then x to the third over x, we subtract those exponents to just give me x squared. Okay. Second term, 12x squared. When I take out a 4x, what's going to be left? 3x. Good. So a plus 3x. 12 divided by 4 is 3. X squared divided by x is x. And then last but not least, negative 24x. When I take out a 4x, what is going to be left? Yep, negative 6. But is there an x left? Nope, they cancel. So just negative 6. And that's my answer. Okay? Questions on that? Sweet. Okay, I want you to try the next one. It just got 2 terms. What do those have in common? So what can you take out of them? Sorry. All right, Brooke, what do those both have in common? T. Good. They both have 1 t, or t to the first, okay? Awesome. They didn't have any coefficients in common, so we don't have to write any numbers out with it. When I take out a t, so when I divide t to the 7th divided by t to the first, how many are left? 6. Okay? And when I divide negative t by t, what's left? Is there a t left? No, but is there a negative 1 by chance? Yeah, because we had a coefficient of negative 1. Cool. Questions on that? Anybody got a question? Okay. We're going to keep on rolling through here. What do we use that factored form for, or why do we factor? Okay, so factored form is used to find the roots of polynomial equations. So find the roots or the answers. Sometimes you might even hear me say the intercepts of a polynomial equation. Okay, it's basically how many times it crosses the x-axis and where at. Okay. So, given the following polynomial in factored form, go ahead and solve it, okay? When they've given it to us in factored form already, this is the easy part, okay? Because we don't actually have to factor it. All we've got to do is set all those factors equal to 0 to find our answers, or our roots, okay? So looking at this, I want everybody to look here. Do we all see how this 2x is out front? That's what they pulled out, We all see that? Okay, so that's going to be one root once we solve it. Do we all see how x minus 4, that's another term that's being multiplied by that 2x, right? And then last but not least, it's set equal to 0, which is what we want, okay? So what we're going to do with this is we're going to take that very first factor, which is 2x, or that very first term is what I meant, 2x, and set that equal to 0. We're breaking these apart, okay? Then we're taking the next term, x minus 4, we're also setting that equal to 0. These two equations are now going to give me my two answers, and then I'm done, okay? So solving this very first equation, how do I move that 2 over to the other side? Divide. What is 0 divided by 2? 0. So x is 0. That's my first answer. Next equation, what do? I add the 4 over, so x equals 4. X equals 0 and x equals 4. That's my two answers. That's it. I want you to go ahead and try number 2. Okay, so again, it's in factored form, so they've already broken down my terms. How many terms do I have here? 2. So go ahead and just break them apart. They're set equal to 0 already, so you don't have to do anything but break them apart. Krista, help me out. How did you break these apart? Perfect. X minus 3 is 0 and x minus 9 equals 0. Great. And now we go to solve these. The first one, how do I move that 3 over? Add it. Okay, we got to use inverse operations. So x equals 3. 0 plus 3 is 3. And the next one, add 9. Good. And x is 9. Okay, you could write it separately like that or like this. Oh, not like that, just like this. Okay, cool. And number 3. What do we notice about number 3? It's different. What'd you say? It's got an exponent, right? It's got an exponent of 2. Okay, so normally, let's say for instance, I had 4 squared. What would that be? Wouldn't it just be 4 times 4? Right? Or x squared is the same thing as x times x. So if I have x minus 1 in parentheses being squared, how would I write that? See? You with me? Because we've got 2 of them being multiplied by each other, right? Okay. Are they set equal to 0? How many factors do I have? 2. Okay. So I'm ready to break them apart. X minus 1 is 0. X minus 1 is 0. We'll go ahead and solve them. What does x equal? 1. What about the other one? 1. I'm just going to write it one time. But yes, it would be 1. We have 2 solutions of x equals 1. All right, go ahead and give number 4 a shot. Only thing different about this one is we've got 3 terms instead of 2, but it still works the same way. How do we solve this? Split them up, okay? First equation. Second equation. Third equation. Perfect. Raise your hand if you made it that far. Sweet. Okay, keep going now. We just got to solve these. First one. Inverse operation of +1 would be -1. So x is -1. 0 minus 1 is -1. Cool. Inverse operation of -3. +3 on both sides. What's 0 plus 3? And last but not least, +2. So x is 2. My 3 answers. Raise your hand if you got all of those. Awesome. Good deal. How do we feel? Scale of 1 to 5 on this. 5? Sweet. Okay. Okay, so unfortunately, they don't always give it to us in factored form, okay? But to solve a polynomial in standard form, we can put it into factored form. And that's what we're going to learn how to do. Because that's what the factoring unit is all about. Woohoo! Yeah, good. Okay, so looking at this first one, 2x squared plus 8x equals 0. Okay, GCF. Let's start with the coefficients. 2 and 8. 2, right? They both will have a 2 go into them. Okay, what about x squared and x? What will go into both of those? X. So 2x is my GCF. Now I'm going to pull that out of both terms. So 2x squared divided by 2x is just going to be just x. Good. 8x divided by 2x is going to be plus 4. Good. The x's cancel and 8 divided by 2 is just 4. Equals 0. Good. Now does this look like what we just did? Yes. It sure does. What's my first term? 2x, set that equal to 0. What's my second term? Set that equal to 0. Okay, the first equation, inverse operation of multiplication is division, so I need to divide by, what's 0 divided by 2? 0, so x is 0. Second equation, inverse operation of adding 4 is 0 minus 4. 0 minus 4.
-4.
Okay, my 2 answers. Questions on that?
This is the last thing we're doing.
No,
Like before we move on to our actual work.
No.
Look, we all listed.
Okay. Number two. Is that set equal to 0? I need everything on the side by itself. How could I move something over?
Subtract 15n.
Subtract the 15n, that works. So I now have 6n squared minus 15n equals 0. Now I need to find my GCF, pull that out, and set my 2 terms equal to 0, okay? I want you to go ahead and try number 2, number 3, and number 4. I'll give you a few minutes. So go ahead and try those. You can work with somebody around you. Looking at 6n squared and negative 15n, what do they both have? Sean, help me out. Yep, what do 6n squared and negative 15n have in common? 3n, perfect. And when I take out a 3n, 6n squared divided by 3n is?
2n squared.
2n. Yep. 6 divided by 3 is 2. And n squared divided by n is just 1n, or n to the first. Okay? Keep our subtraction sign. 15 divided by 3 is?
-5.
Yep. And then n divided by n, they cancel out. So these should be our 2 factors. 2 factors. We set each term equal to 0.
3n equals 0. Oh.
Okay, first one. Divide by 3, n is 0. Next one, we would add the 5 first, right?
Yep.
To get 2n equals 5. And then we would,
Divide by 2, but what's that?
so what is 5 divided by 2?
5 over 2.
5 over 2 or 2.5, whichever one you put, I will take. Cool.
Alright.
Questions? All right, number 3. Start with the coefficients, 3 and 9. What do they both have? 3. S squared and S. S. That's my GCF. 3 divided by 3 is 1. And S squared divided by S? S. So we just have a 1S. Negative 9 divided by 3.
Negative 3.
Yep, minus 3. S divided by S. Just cancel, right? Yeah, cut that out. All right. 2 different terms here. What's my first term? 3s. I need to set that equal to my second term. And what are my 2 answers here? Perfect. 0 and 3. That was a handwriting problem, Brayden. Number 4. Can I factor this one yet? Not yet. What do I have to do? Yep, subtract the 2x over. Good. So 4x squared minus 2x is 0. I now have 0 on one side. Go ahead and solve this one if you have not done so already. GCF, what is it on this one? 2x. Good. When I take that out, what's left?
You have x.
I do have an x and a 2. Yep, 2x. And then negative 2x divided by 2x is just negative 1. Yep. 2x divided by 2x cancels out, but I still have a coefficient of negative 1. Or constant. Okay, cool. Now I got 2 terms. What do I do with them?
Bring them down or whatever.
Yep, break them apart. First equation is going to be
2x equals 0.
perfect. And second equation?
2x minus 1 equals 0.
Okay, the first one I just divide by 2. What is 0 divided by 2?
0.
Next one, what's the first thing I should do on this?
Add 1 over.
Add the 1 over, and then what? Then divide by 2. So my answer is 1/2. Questions on that? Okay. Last new thing we are learning. Last new thing we are learning today. It's called factor by grouping. Factor by grouping. Okay? We will use factoring by grouping whenever we have a polynomial that has 4 terms. Please make sure you underline, highlight, star, whatever you need to do. 4 terms. That's the only time we use this. Okay? So given the following example, it wants us to follow the steps and factor this by grouping, okay? First step is to group the first 2 terms together and the last 2 terms together. So for instance, we're going to walk through this example right here, okay? So the very first thing I would do, my first 2 terms would be what? Y to the 3rd plus 3y squared. I'm going to put those in parentheses on their own. They're grouped together. I'm always, always, always going to put a plus sign between that set and the next. And then I need my last two terms, and what are they? 4y plus 12. You with me so far? 4 terms, first two together, second two together. We use parentheses to do that. Next thing we do, we find a greatest common factor, you can abbreviate GCF, that exists between the first two terms and a different one, most of the time it's different, that exists between the last two terms. Okay? So if I look, we'll start off with our first set of parentheses here. Y to the third and 3y squared. We'll start with the coefficients. What do 1 and 3 both have in common? Just 1, okay? And what about y to the third and y squared? So if this one's got 3 y's and this one's got 2, what do they both have? 2. So I can take out a y squared. When I divide, y to the third divided by y squared is just going to be y, because we subtract the exponents. 3 minus 2 is 1. Okay. 3 divided by 1 is just going to be 3. And y squared divided by y squared, don't those cancel? Yup. Okay, so this is what we've got. We just found a GCF of the first two terms, and we took it out. Okay, we keep our plus sign. Now we've got 4y and 12. What do those have in common? 4. Do they have any variables? No, because the 12 doesn't have one. So now I'm taking out 4. 4y divided by 4. 12 divided by 4. Plus 3.
Do we just equal that all to 0?
Hold on. Step 3, it says, if you have done this correctly, what you have left inside both sets of parentheses should match perfectly. It should be identical. Do we see that this y plus 3 matches this y plus 3? Those are the same? Yeah? Same sign, same variable, same number? Okay? The last step then is to take your two GCFs and to put them together in their own set of parentheses and then keep the same set of parentheses. So what I mean by that, my GCFs out here were y squared plus 4, so that goes in one set. And then the y plus 3 is in the other. And that is all. That's my answer. Those are my two factors. That is how we factor by grouping. It is weird, okay? But once you get the hang of it, it's actually really easy. But you just got to do some practice. Okay? Anybody need more time with this example problem? Everybody got that down? All right, we're going to do another one together, and then I'm going to turn you loose. Okay, so 5t to the fourth plus 20t to the third plus 6t plus 24. How many terms is that? 4. So we need to factor by grouping. Woohoo. Okay. I'm going to go ahead and group my first two terms. In a set of parentheses. I'm going to put a plus sign. And now I'm going to put my next two terms in a set of parentheses. Okay. Looking at my first two terms, just starting with their coefficients, 5 and 20. What goes into both? 5. And I've got t to the fourth and t to the third. What goes into both?
3.
Yep, 3 t's, right? So t to the third. Now we're going to see what's left over. 5 divided by 5 is just... What? You say 4?
1.
Goodness. Yeah, 1. And then t to the fourth divided by t to the third. How many t's are left? 4 minus 3. 1. So 1t. And then we've got 20 divided by 5 is going to be 4. And t to the third divided by t to the third. Cancels out, right? Keep my plus sign. What do 6t and 24 have in common? Just 6. 6t divided by 6 is just t. And 24 divided by 6 is 4. Do my parentheses match the insides? Yep, so my very last step is just to take my outsides and put them in one set of parentheses and leave my insides. That's all. You gonna be all right, Carson?
Yeah.
Yeah. Okay. Take a deep breath. All right. I want you to go ahead and try example 2. You can do it. All right. So, first things first, we've got to group them up. Okay, what's going to be in my first set of parentheses? 2w to the third plus w squared, good. Plus sign, and then what's in my next set? Perfect. I did write it down. Okay. First, starting off with the coefficients in the first set of parentheses, 2 and 1. What do they both have? Just 1. Do we have to write an invisible 1? No, but you can if you want to, okay? Moving along to the variables, w to the third and w squared. What do they both have? 2. 2 w's, w squared, right? Okay. 2w to the third divided by w squared. What do we get? What's left over? So 2 divided by 1 is 2. And w to the third divided by w squared. Just w. Okay. And then we keep our plus sign here. W squared divided by w squared. Just plus 1. Good. Next up, coefficients in the second set of parentheses. We got negative 14 and negative 7. What do they both have? Negative 7, good. Negative 14w divided by negative 7 is going to be? Negative 14 divided by negative 7, Timmy. Positive 2, okay? With a w. And then negative 7 divided by negative 7. Plus 1. Do my parentheses match? What happens if they don't match? Nope, it's not a no solution. It means you did it wrong. Okay, I'm not going to give you a problem where it doesn't work out. So if you don't get matching parentheses, you did something wrong. So go back and look. Okay, very last step then is just to rewrite what's going to be in the first set. Yep, outsides. And the second set. Perfect. All right. This next one is pulling out the greatest common factor before you begin. Okay, so if there is a GCF, you need to take it out beforehand. We're actually going to skip over this one just due to time. All right, now we're moving on to solving. We're throwing a lot of things together here. That's okay. Is everything on one side yet? No. So what do I need to do? Move it. What should I move? 4x and the 4. Yep, just subtract them over, right? On both sides. So then I get 1x to the third plus x squared minus 4x minus 4 equals 0. What do you think we're going to do here? Same thing we've been doing, okay, but we've got it set equal to 0. So basically we're going to factor by grouping, set our answers equal to 0 so that we can get our intercepts or our roots, okay? All right, I want you to go ahead and try to factor by grouping this one, because this is a really easy one, okay? And then we will try to get through this one before we go to lunch. All right, your first two terms are what? All right, you should be following along up here, guys. I'm breaking these apart into two sets of parentheses. My first set, they don't have any coefficients, so I don't have to worry about that. X to the third and x squared, what do they both have? X squared. What's going to be left? Good, x plus 1. Next set, what do both of those have in common? Just a negative 4, and when I take that out, it should also get x plus 1. My final answer then, or not final yet, x squared minus 4 times x plus 1 is 0, and then I set both those terms equal to 0. We'll pick back up after lunch. Okay, so then we need to just set both of these equal to 0. First one, add the 4 over, so x squared is 4. We would then need to square root both sides to get x is 2 and negative 2. And x is negative 1. So we've got 3 answers there. Moving right along, we're actually going to skip these last two, but we are going to do number 2 real quick. Our GCF would just be, if we're looking at the coefficients, 3. Both of these have an s in common, so 3s. 12 divided by 3 is 4. S divided by s cancels. Keep that subtraction sign. 3 divided by 3 is 1. And s to the third divided by s is just s squared. Set both terms equal to 0. First one, we just divide by 3, and s is 0. Next one, we would subtract the 4 over. Divide by negative 1. So s squared is 4. And then same thing as before, we'd square root and get s is positive 2 and negative 2. So 3 answers there as well. Okay. All right, there are 5 Delta Math problems online waiting for you, and there is also a homework assignment. Let me know if you have questions.